This is another example video involving solubility product constants. In this problem, we're going to use KSPs to predict whether or not a precipitate will form upon mixing of two solutions. And so in this problem, we're mixing silver nitrate with sodium sulfate. And so to understand what's going on, I think it's helpful to write the chemical reaction that would occur when I mix these two solutions. And so we have silver nitrate sodium sulfate, and so in order to predict the products of this reaction, I need to know what ions I have present and what the charges are. So I'm going to write the ions underneath the reactants. So silver nitrate is going to dissociate into Ag plus and NO3 minus. Sodium sulfate will dissociate into sodium plus 1 ions and SO4 2 minus ions. So when I predict the products, I need to look, I'm going to swap the cations and the anions. So the silver is going to combine with the sulfate, and the sodium is going to combine with the nitrate. And so our products, when I look at the silver sulfate, because sulfate has a charge of -2, silver has a charge of +1, that's going to be Ag2 SO4, and sodium and nitrate each have magnitude, their charges have magnitude of 1, so the formula of that will just be NaNO3. And so in order to know whether or not a precipitate will form, I'll have to know which ones my solubility rules would predict would be insoluble. So if I go look at my solubility rules, I see that all common nitrate and sodium compounds are soluble. So we would expect that guy to be aqueous. And under the solubility rules, they tell us that most sulfates are soluble, but the exception, one of the exceptions, is silver. And so this is our potential precipitate. And so this is what we're going to focus on in this problem. Now, the fact that they gave us the KSP of silver sulfate is sort of a pretty big hint that this is the one that we need to deal with. And so if we were actually working this problem on a test or something, I wouldn't have to do all this and figure out what the products are, but I think it's useful in helping to understand what's going on here. So this is the compound I need to focus on. And so if I'm using KSPs, the chemical reaction I need is the equilibrium for this reaction. All right, and so in order to solve this problem, it turns out it's just predicting reaction direction. So it's a Q versus K problem. So I need to calculate Q and compare that to K. Now that will tell me which direction the reaction is going to go. If the reaction is going to go to the left, then I'm forming more reactants and a precipitate will form. If I figure out that the reaction is going to the right, then that means that my solution is not saturated and I can actually dissolve more silver and nitrate, or sorry, silver and sulfate in the resulting solution. So in order to calculate Q, I need the initial concentrations. And I can't just use 0.2 and 0.15 because when we mix these solutions, the new solution volume will be 50 milliliters plus 75 milliliters. So let's figure out our concentrations on the next slide. All right, so I've just rewritten the reaction for the equilibrium process that we're interested in, and I need to know the concentrations after the compounds get diluted when we mix them, right? So for dilutions, we need to use M1V1 equals M2V2. So for the silver, the initial concentration was, we're solving for M2, so we need to do M1 times V1 over V2. The initial concentration of the silver is 0.2. The initial volume is 50 milliliters. And then the final volume will be 50 plus 75, or 125. And so the concentration of silver is 0.080 molar. Do the same thing for the sulfate. So again, M2 is M1V1 over V2. The initial concentration of the sulfate is 0.15. I have 75 milliliters of it. Final volume is again going to be 125. And I get a concentration, of sulfate of 0.09 molar. All right, so using these concentrations, I want to calculate Q, and I'll do that on the next slide. So remember, the equation for Q is just the same thing as the equation for K. It's just that when I have a Q, I'm using the initial concentrations. And so my Q is equal to the concentration of silver squared, because of the 2 in the balanced chemical equation, concentration of sulfate to the first power. So now I can just plug in the initial concentrations we found on the last slide. And when I multiply that out, I get a value of Q of 5.76 times 10 to the minus 4. And so now to determine whether a precipitate forms, I need to compare Q to K. So Q is 5.74 times 10 to the negative 4. K is 10 to the negative 5. So Q is bigger than K. And so I have too many products. There actually needs to go to the left to get rid of them, right? Or Pac-Man tells me the reaction is going to go to the left. And so if this reaction goes to the left, then I'm forming Ag2SO4 solid. And so that means a precipitate will form when these solutions are mixed.